Hello, fourth grade. Sorry about the technical difficulties earlier and that this is not live, but I hope we still have a good time today on this June 1st day, Monday, learning about electricity. So the first thing I'd like you to do is think about all of the different ways that you use electricity in your home. We use it for dishwashers, refrigerators, computers. You're using it right now to listen to me. I'm using it right now to record this and talk to you. Now, when we're talking about electricity, the first thing we need to review are what are our parts of an atom? So I'd like you to think in your head right now, what are the parts of an atom that we've already learned about? Okay, so here's our three parts of our atom. So we have the nucleus in the middle, and our nucleus is made out of protons. These have a positive charge, excuse me. We have neutrons, which have a neutral charge, as in there is no charge to them at all. They are neutral. They are neither positive nor negative. And then on the outside here, around our nucleus, are our negatively charged particles called electrons. Now, the first thing you might notice is that we're learning about electricity, and this particle sounds a lot like electricity. It's called an electron, and they're negatively charged. So what is electricity? Electricity is the flow of electrical charges. Charges flow in a current like water flows in a river. So when they're talking about charges flowing, what they're talking about is actually electrons flowing. So we take electrons, which are on the outer part of atoms, and we kind of move them along the same way water moves along in a river. So here's some GIFs of how electrons move. For example, on these GIFs, I'd love it if you could just put your eye on one of these electrons and follow it down the line. Same thing down here. These little green dots are our electrons going around their nucleuses, and they're going down the line. So they're kind of hopping from one atom to the next. And this is our electron flow. This is how electrons move down a copper wire or move down when we are using electricity. Now, if you've ever looked very closely at a battery, you might notice that they have charges written on them as well. So the positive side of the battery takes the electrons, and the negative side of the battery gives the electrons. We'll talk more about that in a second, but first let's make some observations about these batteries. If we look at this battery over here, we can see a little plus sign on the copper side of it, and then the black side of it on the flat side on the other side, that would be the negative side of the battery. So the plus side indicates that it is the positive side, just like a magnet. Over here we have another AA battery. So we have a positive side and a negative side. Now here I believe this is a it's a 9-volt battery. So we have the positive side, which is this prong here, and we have the negative side, which is this little indent here. And then over here we have a car battery. And then we have the positive node over here, which is in red, and then the negative node over here, which is in black. Now, it's important that batteries have a positive and negative side because, as I said before, the positive side of the battery takes electrons and the negative side of the battery gives electrons. Let's look at what that might look like. So here I have kind of a funny looking GIF of two hands giving and taking electrons. So here we can see a positive battery taking the electrons. If we watch this red electron move down the line, And then the negative side of our battery is giving the electron, moving down our atoms. Very important stuff to know. Now, one thing that we should remember about electricity is that electricity is not fire. The electrons move from negative to positive in an electric circuit, like we just saw. The electrons inside of fire, the atoms in fire, they move very randomly. So, with our electrons here, they are moving down a line. They have a pattern that they follow. It's called the electron flow. With the atoms and electrons inside of fire, they are moving very randomly. They don't have an order or a path that they follow the same way they do in electricity. So electrons give a charge. Gaining or losing electrons makes an object have a charge. Gaining an electron makes it have a negative charge because the electrons are negatively charged. Losing an electron makes it have a positive charge. Oh, and then this is some good vocabulary to know. If an atom either gains an electron or loses an electron, it is called ionization, and then that atom is called an ion. Now let's learn a little bit about static electricity. Static electricity is the buildup of electrons in one place. So an example of this is getting shocked by a doorknob. Or sometimes you might get shocked by a friend, and that's because we're building up a bunch of loose electrons, and they are releasing once we touch a very good conductor or something that can handle those electrons. Lightning is also static electricity. It is a buildup of electrons in the clouds through air movement, and then they release. So let's talk about what electricity flows through. So when we were discussing heat, we talked about conductors, which could easily let heat pass through them, and insulators, which do not easily let heat pass through them. So for example, maybe an iron pan would be a good conductor. Heat passes through it very easily, and that's why we use it to cook. And then an insulator would be like an oven mitt. It does not let heat pass through it, so we use it to hold on to hot things to protect ourselves. Now, electricity can go through their own kinds of conductors and insulators as well. There's also these things called resistors, and we're going to talk about what those are. So when we're talking about conductors and electricity, conductors are materials that allow electricity to flow, like copper or aluminum. So a lot of metals make very good conductors, and that means electricity can flow through them. That also means that those electrons can easily be passed from one atom to another down the line in the atoms that make up these metals. So conductors allow electricity to easily flow. Insulators do the opposite. They do not allow electricity to flow, like rubber or plastic. That's why when we have wires, we coat them with rubber or plastic. If you go to any electrical device in your house, you're going to see that they have a plug and they have a long cord going to the device. Now, I bet you that the material that is surrounding that cord is wrapped in rubber or plastic. And then in the middle of it, you're going to have your conductor, which is going to be a type of metal. If you can ever see the metal inside of your cord, if the metal is ever hanging out of your electrical cord, I highly recommend no longer using that electrical cord because it is not safe anymore. And we're going to talk about why that is in a little bit. Also, electricians, when they're doing their work on power lines, a lot of times they have rubber gloves or they'll have big rubber boots. And this is to protect themselves from the electricity because electricity does not easily pass through rubber. It is an insulator. Now let's talk about resistors. Now, when electrons are moving down in the electron flow, like we saw those two hands pushing them along and pulling them along, there is a speed which they are going to be moving. Resistors can slow the speed of the electrons flowing. So how they do that is by using some of that electrical energy and turning it into a different kind of energy. So resistors are the things that use electricity. For example, if we have electricity going down the line of a wire, and then it has to pass through a fan or a motor, that fan or motor is going to use some of that electrical current, some of that electrical flow, and it turned that electrical energy into mechanical energy, also known as moving something. So it's going to be moving those fan blades. So it's going to be slowing the electrical current because it needs to use some of it. Same thing if we were making light or if we were producing heat or sound. Resistors are things that use electricity and convert it into these other kinds of energy, such as heat. Okay, let's talk about a circuit. Now, an electrical circuit is kind of like the path that we're going to force our electron flow to go in. So, an electric circuit is a continuous pathway that can carry an electric current. Here we have a closed circuit. So we have the electrons being given by the positive side. They go through their path. They hit our light bulb. They go through the filament. So they come up through a wire in the bottom of the light bulb. They go through the wire in the middle of the light bulb. They heat up that wire. And they heat it up so much that it starts to glow and produce light. Then, after those electrons pass through that filament, they come back down. And then they're going to enter this wire and then go back to the negative side of our battery. This is called a closed circuit because the electrons that come out of our battery are going to return back to our battery. Now, if there is any break in the circuit that makes this incomplete, if there's an open section of the circuit, like if I cut this red wire in half or something like that, it is going to be an open circuit. So any break in the circuit will stop the electrical current. This is called an open circuit. Now, there is no electricity flowing in this circuit because the battery knows if it sent out electrons in this side and it goes to the light bulb, then there's no way for it to get back to the negative side of the battery. Another way to think about this is not only is the positive side of the battery having to push out electrons, the negative side of the battery also needs to pull them in towards it. So this circuit over here on this side is not feeling the pull of the negative